Here's a first example where we're looking at working with the roots of alpha and beta. Okay, so a couple of questions here. First of all, we can find the series of alpha and beta using the equation. So let's have a look. First of all, alpha plus beta. Let's see, alpha plus beta equals negative b over 2a, beg your pardon, negative b over a, which in this case is negative 4 over 2, which is negative 2, and alpha beta is c over a, and that gives us 1 over 2, which is a half. Now, the other questions you'd be asked then is finding things like, alpha squared plus beta squared. I didn't really need those brackets. Okay, now what we're trying to do here is find alpha, find this stuff here in terms of the first alpha and beta, alpha plus beta and alpha times beta, the sum of the product. Okay, so one of the rules you'll have to recognize is alpha plus beta squared, all squared. Well, when we square the first, we get alpha squared. When we square the second, we get beta squared, but we also get 2 alpha beta in the expansion of this square. So we have to subtract 2 alpha beta to keep this thing in balance. And now we can substitute from above, and that equals, well, alpha plus beta was negative 2, and that's squared, and 2 alpha beta was a half. Okay, and what we end up with is negative 2 squared is 4 minus 1 is 3. So we can see that it works, how we get those sort of alpha squareds plus beta squareds and a variety of other things. Another example might be find 1 on alpha plus 1 on beta. Now all of this is just algebraic manipulation using the values of the roots. Now we're going to cross multiply to get beta over alpha, and we're going to multiply the top and the bottom by beta in this case. And so let me just show you what I'm doing here. Okay, that's going over there, and that's going over there. Okay, there's nothing new there, so plus alpha on alpha beta. Right, so now what we've got is alpha plus beta on alpha beta, and we substitute and solve that equation. And there's a variety of other methods. Here's just one more example, 2 alpha plus 2 beta. Okay, well that's nice and easy. We just take 2 outside of alpha plus beta, and away we go. So there's a couple of examples of using alpha plus beta and a variety of ways in which we can, well, I suppose, use it in different formats. There's a couple of examples there. Okay, if we move on and just look at this example where we've got an equation of 2x squared minus 15x plus c, where one root is 4 times the other. Now, in other words, what we've got is there's a root of alpha and there's a root of 4 times alpha. You could use beta and 4 times beta, it doesn't matter. Now, what we know is that the sum of the roots, the sum of the roots is negative b on a, and the product, so what we've got is 5 alpha equals negative b on a is negative 15 on 2, which is 15 on 2, and dividing both sides we get alpha equals, divide both sides by 5, we get 3 on 2. Okay, we know alpha is that, so 4 alpha is 4 times that, which is 4 3s are 12 on 2, which is 6. So now we can find the equation, well, if I've got roots of, so again, if I've got 1 root of 3 on 2 and 1 root of 6, I could put that into the equation and solve for c. The other way to do it is to do the product of the roots, which is alpha times 4 alpha, equals c on a. In this case is 2. Now we know that alpha, or what do we get, 4 alpha squared. There are shorter ways to do this, but by way of demonstration, 8 alpha squared equals c. So c equals 8 times, now we found alpha already, 3 on 2 all squared. Now that's 9 on 4. 9 on 4 times 8. Sorry, what do you got? 9 on 4 times 8, and that cancels, 2 9s are 18. So C is 18. Okay, so there's a couple of examples of how we use the roots